Hello everyone, this is Anil and you are watching the YouTube channel Neelkamal classes. So I welcome you all in my YouTube channel, and if you are new on this channel, then I request you to subscribe the channel, like the video, give your comment, and if possible then share this video with your friends. So now we are studying Lagrangian dynamics, and in Lagrangian dynamics we have made 4 videos. This is 5th video. So till now in last class we have studied about constraints. So if you haven't seen that video, then link is in description. You can go through that video, and it will be helpful because now we will continue that video. So that is the first part of that constraint, and in second part today we will see the classification of constraints. So if you are visiting first time on this channel, then I request you to go through all 4 videos. So it will be helpful for you, and you will be understand better. So let us start today's topic. So now we are studying Lagrangian dynamics. This is your Lagrangian dynamics, and in this one last class we were studying about constraints. So and we will see we had seen the definition of constraint, and we have taken in last class we took some examples. At least I have wrote means 3 or 4 examples. So we will continue from that example only, and based on those examples we will try to classify the constraint. So for it means basic information I told in last class also I told that degree of freedom we have to make this means degree of freedom was 3n minus k. So this is our k is constant, and this topic we are studying now. So in last class we took some examples, like first example I think like taken here. I have kept some m mass and this one theta. Second example I took like this. One box was there, and I told that some means some particles is there like this. So like this. Third example we took that was, let me do it. I'll make it here so it will be helpful for us, like this, and it's like that. Third example we took was simple pendulum. It was like this, and the 8t time. Let me consider it there. Fourth, I think that example I took or not. Wait, let me write. It will be helpful for in classifying. So I am taking one more example. If I have taken in last class, in previous class, then it's good. Or if I did not take, then let me write it. There I am considering one pulley, and that I have one rope or something. So using this one, and this is the length L. So what it means, let me draw first. After that I will tell you the difference between this one and this one. This means if you wait, this is pulley, and 80 times it's there like this. So in this one what we are taking, we are fixing that like means length L here. This is like L, and this is the fixed. So the ball is moving in specified, that means path. But if you observe in this one, I am taking here a rope, and through this pulley I can increase the length L if I want to increase. Means after t time, if I want to slowly, I want to increase. After some time, means if I give that some rope, that it will increase. Similarly, if I want to decrease, then according to time I can decrease the length. So this is the difference between them, and we will while classifying the constraints, we will means you will find this difference between them, importance of that call. So in first example, if you see, then if I ask you to write the expression, I think you can write easily. You can write it like this. If I can say ax plus by plus az is equal to constant d. Then for this we can write this equation. So because how can in this one I last class only I told that if M mass is heavy constant and it's moving in that it can move in AB plane only. It can't go in other. It can't follow in any other path. So if I ask you means let me take one some particle is there. I have this particle, and if I ask you that to define those particles, so in this one we cannot tell that exact position of the particle means it, but some we can tell something we can tell. What can we tell? That particle will be inside that box. It cannot go outside. So that restriction or that constraint is that means it particle will be always it will be stay in that box. So for that if I want to show in that, then I can write. If I consider this is x-axis, this is y-axis, and this is the z-axis, then I can write. Let me take this is L, this is B, and this is H. So I can define like this. The particle, if I want to consider x-axis, then let me take that the position of particle will be x because it is varying. So I am taking x will be always in x-axis. It will be always 0 to L. Maximum length is L for this box in this. If you move then maximum is L. So it particle will be either till L to 0 it will be particle will be in x-axis it will be there. If I say in y-axis then y-axis H is there. So it will similarly it will be H. And if we see z-axis then we can say B. Like this we can define. So this is the thing we can say in this type of constraint or examples of constraint. Now we will go for example number 3. Can we explain or can we write something equations or expression like this? So if you see that if I say that this is a rigid rod, same, pakka it will follow same path. Going to see like this. Whatever it will circular path. What can I say? I can say that x square plus y square is equal to length is L is constant of L square. This. What about the fourth example? Can you see? In fourth example, how can we write an equation? Can we write? And if we cannot write, then this constraint is there. So how can we define that position of that pendulum? If I ask you to define that, so what how can we do? We can take. We can write it as an equation, but problem means difference will be that equation will be dependent on time. According to time means if I want to change that length, if I am changing that length of that pulley according through pulley, so length will be changing, but we can write it as equation. So how can we say? We can write x square plus y square is equal to L square. That and this L and this L are not same. It will be changing according. It's changing according to time. It's constant. So what can I for better? I can write it function of p and square. So here our L is changing according to time, but here L is not changing. So these are the 4 examples I have taken, and through this we will try to classify the constraint. So let us see classification of constraint. Now, if I ask you, can you find any difference between all this? For example, can you observe any difference in 4 examples? So I think you are thinking that because there are 2 major differences we are finding, that some examples are there, few examples are there. To them we can write them as equations. So and one example is we got that we can't write in as equations. So if I'm not clear about equation, then let me tell you that equation is nothing but it's a equation is, if we see the word only, we can say that equation means containing equal sign. So in this one, this is containing equal sign, this is having equal sign, this is. So these are the major 2 differences. So on this basis only we can do that. The constraint is classified. One, that there are 2 major difference or The two types of constraints are there. One is holonomic and second is non-holonomic constraint. So these are holonomic is nothing but we can express it as equations, and non-holonomic we can express isn't we cannot express it as a equation. So if we say example, this example is for this, and all other examples will be for holonomic. So these are, and if you are getting very about that definition, because I did not use much theory, I did not write any theory. So what is, don't worry about that. At last of the video, I will add some screenshot. There you will find that definition of these things, so you can write through that. You can take screenshots later. You can. So these are the two differences. But okay, so I think you two examples you got understood, means what I mean. Then I told you that why I wrote this. I have taken two examples. There is a reason I have tell that, means later you will understand. So let us see why we have taken. So the classification of constraint is based on time also. This is another one, and if we see and based on time, then we can classify it as means two more examples, more types. Like one will be here we means divide in the base of equations. One we can write express as equation. Second we come there will be what is their base difference will be there, means that some constraint will be that equations or expression will be changing according to time, and some of them will be constant or does not depend on time. Like this is the equation. This is the equation is there, but this is changing with time. If I want to show that non-holonomic type, then what can I show? Let me take one example. Similarly, I have one box. One more example. Like this. And what I am doing, this is my z-axis, x-axis, y-axis, and I am changing that this length is, this L is increasing but with respect to time. Similarly, if I want that B, if I take B also I can take that B will be increasing. So what I mean that box which I have made, it is getting bigger with according to time. So this is also dependent time. So if I want to that show that position of a particle or constraint on a particle, I can write that it will be x will be, and this is L. So L t I have to write, because L is the function of t. According to t, the L is changing. So this type of examples are depending on time. This is depending on time. So for this one, we can classify two more examples for two more types. That is, which is we can write scleronomic, and second is rheonomic. So scleronomic is what is that will not does not depend on time. Does not depend on time, and this will depend on time. So based on the time also two types are there, based on equation or means we can express as equation or not. This is two types. So total constraints if we ask, means if we see, there are four types of constraints are there. Main is holonomic, non-holonomic, scleronomic and rheonomic. So these are the four examples, and I think there's four examples which I taken, fifth also I have to. So these are helpful for you to understand. And in next class we will use that Newtonian mechanics. In the sense we will use that formula. I think if you don't know about Newtonian mechanics, then I think you know this formula. To have force, we can express it as a dp by dt, change in second law of motion, and we can write it as a p dot. P dot is nothing but dot we will use for d by dt. So if I want to remove this one, I kept it dot. So we will use this one. Using this one, we will understand, and the next topic will be this next class. Using this one, we will understand. Then we will start the generalized coordinate. So first we directly we want to go general. We will understand why we need of generalized coordinate. Then we will see next general coordinate. So today we will finish our video here. And if you want to move next video directly, then after getting video ready, we will keep the link of that video in description, so you can go directly. So we will see next class. Thank you. Bye bye.